The global energy transition is not a single event. It is a multifaceted evolution of how we produce, store, transmit, and use energy. At the heart of this evolution lies a clear sequence. First, electrify everything we can, then deploy green hydrogen for sectors where electricity cannot go, and finally anchor the system with nuclear power, a clean and firm energy source. In this journey, one of the most visible companies, Tesla Inc., offers a compelling illustration of how electrification can scale, expand, and integrate into broader energy systems. This is not simply Tesla's story. It is a story of the entire clean energy ecosystem, shifting from fragmented technologies to unified systems. We begin with the first pillar, electrification. When you plug in a car, install a heat pump, or connect a battery to your solar array, you're moving toward a world powered by electrons rather than combustion. That single change brings cascade benefits: higher efficiency, lower emissions, and simplified infrastructure. Electric vehicles, for example, convert more than 90% of the electrical energy into motion, compared with the less than 30% typical of internal combustion engines. Heat pumps can deliver 2 to 4 units of thermal energy for every unit of electricity consumed. These efficiency gains are the foundation of the clean energy future. Looking at the global picture, electric vehicle sales exceeded 17 million units in 2024, representing close to 1 in 5 new cars sold worldwide. In many markets, they are not niche. It's becoming the standard. Heat pumps, once a technology of the niche market, are now moving into mainstream building stock in Europe and Asia. But electrification doesn't stop at devices. It demands systems. Infrastructure must catch up. The world must expand and modernize its grids to transport these electrons. According to estimates from industry analysts, by 2040 we will need to add or refurbish more than 80 million kilometers of transmission and distribution lines globally, comparable to rebuilding the grid of the entire planet. This is where Tesla's role becomes illustrative. Once a car company, Tesla has evolved into a system integrator. Its gigafactories don't just build vehicles, they build batteries, drive trains, electric cells, and integrated energy systems. Tesla's Megapack battery deployments are proving that large-scale storage is not concept, but commerce, stabilizing grids in real time. The supercharger network, now being open to non-Tesla vehicles, demonstrates the power and leverage of an integrated infrastructure. Tesla shows how electrification isn't just swapping fuel, it's replacing entire systems. By designing vehicles, batteries, charging stations, and power software as one ecosystem, Tesla points the way for others. But electrification has limits. It cannot reach every process or sector. Some industries require extremely high temperatures, large mass flows, or chemical reactions that electricity alone cannot support cost-effectively. That's where the second pillar, green hydrogen, enters. Hydrogen produced from renewable electricity can act as a vector for clean energy, bridging from electrons to molecules. It can be stored seasonally, transported globally, and used in industrial processes or heavy transport where batteries are not practical. Hydrogen is not a replacement for electrification, but a complement to it. In steel production, for example, hydrogen-based direct reduction replaces coal for iron ore processing. In shipping, hydrogen-derived fuels such as green methanol allow long voyages under near-zero carbon footprints. Aviation and chemical manufacturing are exploring synthetic fuels and hydrogen feedstocks. The fossil era's rigid sectors, cement, steel, ammonia, are beginning to imagine a future powered by hydrogen rather than carbon. However, green hydrogen faces multiple challenges: cost, infrastructure, water use, and logistics. Electrolyzers are still expensive and cheap. Abundant renewable electricity is essential for competitive green hydrogen. Storage and transport, whether pipelines, ammonia carriers, or conversion to synthetic fuels, add complexity and cost. This is why hydrogen projects succeed when they are tightly integrated with their renewable supply, demand offtake, and logistics. The most promising projects cluster around major industrial hubs with policy support and long-term contracts. Tesla's example reinforces a key lesson for hydrogen. Scale and systems integration matter. Tesla did not succeed by simply building cars. It doubled down on batteries, software, charging infrastructure, and closed-loop energy management. In the same way, hydrogen must be built not as standalone plants, but as integrated ecosystems combining renewable generation, electrolysis, storage, transport, and industrial offtake. The future of hydrogen will favor those who understand project finance, systems integration, and offtake certainty. Yet, even with widespread electrification and hydrogen deployment, the question remains: how do you keep the lights on when the wind stops, the sun hides, or demand spikes? The answer lies in firm, clean power, energy that is available on demand, day and night. This brings us to the third pillar, nuclear energy. Nuclear power has long been controversial, but as decarbonization accelerates, its importance is becoming clearer. Nuclear reactors produce zero direct carbon emissions, provide reliable output, and can operate for decades. Modern reactor designs, especially small modular reactors, SMRs, bring advanced safety, lower costs, and faster construction. For example, in 2025, the UK approved the Sizewell C project, one of Europe's largest new nuclear investments. Canada is advancing the BWRX 300 at Darlington. Even countries with strong renewable portfolios are re-evaluating nuclear as a strategic asset. Nuclear is not just about electricity. It is about heat, steam, and large-scale continuous power, key attributes for industrial processes and hydrogen production. A nuclear facility coupled to an electrolyzer could produce hydrogen with high utilization rates, smoothing electrolyzer economics and anchoring the hydrogen system. This is how the third phase connects back to the second. Nuclear ensures reliable power, hydrogen uses that power where batteries cannot, and electrification turns that power into motion, heat, and light. Now let's view the three phases together. Electrification scales fast where possible, hydrogen fills the hard sectors, nuclear provides the grid stability and high utilization backbone. In this architecture, companies like Tesla matter because they show how system integration creates value. Tesla's evolution, from electric cars to energy storage to grid services, reveals how infrastructure and software combine to accelerate the energy transition. But Tesla is only one actor. Governments, utilities, industrial clusters, and emerging markets will all play vital roles. For professionals, developers, consultants, financiers, this means one central truth: systems thinking wins. Projects built in isolation will struggle. It's not enough to build a battery farm or a hydrogen plant alone. The future demands that you link generation, storage, transport, and demand. It demands that you understand cost curves, policy frameworks, infrastructure constraints, and capital markets dynamics. That's the work ReneEnergy.com supports, turning insight into executable projects. We should also consider timing. The 2020s will largely belong to electrification, EVs, heat pumps, storage, smart grids. The 2030s will increasingly shift into hydrogen growth as electrolyzer cost falls, policies mature, and logistics scale. Throughout, but especially into the late 2030s and 2040s, nuclear will rise or remain vital to stability. The investments we make today will determine which countries and companies lead this transition. Finally, envision the world of 2040. Cities that run on clean electricity but are powered behind the scenes by hydrogen and nuclear when skies are dark. Industrial clusters producing green steel and ammonia. Shipping fleets running on hydrogen-derived fuels. Nuclear plants sited next to hydrogen production hubs. Electric vehicles not just transporting people, but charging and discharging to help the grid. That's the future we're building, not by chance, but by design. In closing, the path is clear. Electrify first, hydrogen next, nuclear always. And companies like Tesla show how the shift from product to system unlocks scale. At ReneEnergy.com, we're here to help you navigate this system, build the projects, and seize the opportunity of the new energy era. The blueprint has been drawn. The tools are emerging. The time to act is now.